Indices. Indices. That's the topic, right? So indices is the plural for the word index. So in singular, the word is index. What is an index? An index is simply what we commonly call a power, right? So if we have something like this, a raised to the power n, this thing here, that's the index, what we commonly call the power. So from your understanding, which I hope you have by now, you know that y to the power 1 is simply y. Y to the power 2 means there's two y's multiplying each other. Y to the power 3 means there's three y's multiplying each other, and so on and so forth. So the relationship continues like that. So if a number is raised to the power 1, you just write that number. When a number is raised to the power 2, it means that number is multiplying itself. When a number is raised to the power 3, it means you have three such numbers multiplying each other. Right. But for now, we want to go to what we call the laws of indices, right? We want to look at some laws that we have to obey when we are operating indices. So the laws of indices. Okay, so the first law is a to the power n times a to the power m is equal to a to the power n plus m. What does that mean? If I have two numbers, right, which are the same and they have powers, when I multiply them, all I have to do is add the powers. Okay? So, for example, if I have 7 to the power 2 times 7 to the power 3, this should be 7 to the power 2 plus 3, which gives me 7 to the power 5. That's my result. So that's the first law. The first law is if these two numbers, if this is the same number, right, then you can simply add powers. So it only applies when this is the same number. You can't do it for different numbers there. Let's go to the second law. Law number 2. A to the power n over a to the power m is equal to a to the power n minus m. So in the first law, we were multiplying two numbers. This time we're dividing. So if we divide, instead of adding the powers, we subtract. Okay, so for example, if I have 8 to the power 7 divided by 8 to the power 3, this gives me 8 to the power 7 minus 3, which gives me 8 to the power 4. So that's my result there. All I have to do is subtract the powers. And again, remember, these two numbers, this must be the same number. This law does not apply when these two numbers are different. Now let's go to a slightly tricky one. A to the power minus n is equal to 1 over a to the power n. Now in this case, we had a negative in the power. Now, what does the negative in the power tell us to do? The negative in the power makes us invert the number or reciprocate, right? So you invert and then the power becomes positive. So after inverting, the power does not remain negative, but it becomes positive. So for example, if I had 4 to the power minus 2, this becomes 1 over 4 to the power 2. And if you are interested in going further, 4 to the power 2 is 16, so that's 1 over 16. Okay, so notice that after I inverted, the power became positive. The power does not remain negative. The only function of the negative in the power is to invert this number. Okay? An extension of that same law is if I have a over b to the power minus n, what does this do? Invert, right? B goes over a, and then this is power positive n. So after inverting, right? After inverting, the power becomes positive. Okay, so if I had something like 3 over 2 to the power minus 2, this becomes 2 over 3 to the power 2. And then if you so wish to go a step further, 2 to the power 2 is 4, 3 to the power 2 is 9. That would be your final solution there. Okay? And just a reminder of what some of you may know, a to the power 0 is equal to 1. Okay? If you raise any number whatsoever to the power 0, your answer should be 1. So if I have 70 to the power 0, my answer is 1. If I have 1,37 to the power 0, my answer is 1. So it doesn't matter what the number is. If you raise it to the power 0, you get an answer of 1. So let's look at a few examples, and then you can try some questions. Okay. Let's look at a few examples. Okay, the first one is 3y to the power 2 times 2y to the power 5. So what's happening here? All we have to know is that 3 and 2 will multiply in regular form, just like regular numbers. 3 times 2, that's 6. And then the y's have to obey the first law and add the powers because they are the same. We have a y there and a y there. So this is 6y to the power 7. One thing you need to know is that this power 2 and the power 5 belong exclusively to y. So this power 2 has no effect whatsoever on 3, and this power 5 has no effect whatsoever on that 2. In fact, 3 is the same as 3 to the power 1 and 2 to the power 1. So this is the same as 2 to the power 1 and 3 to the power 1. These powers are exclusively on y. 10x to the power 8 divided by 5x to the power 3. 10 and 5 divide to give you a 2. And then x to the power 8 and x to the power 3 subtract powers. So this gives you 2x to the power 5. 3. If I have something like 2y to the power minus 3, again, you must understand that this power minus 3 does not affect 2. This power minus 3 is exclusively a power of y. So we know that a negative power inverts, right? So 2 will remain the same, but y will be inverted and the power 3 becomes positive, right? So it's now 2 times 1 over 3y. 2 multiplies the 1, you get 2 over y to the power 3. So as you can see, only y is inverted and only y is to the power 3. If we have something like this, however, 2y and then to the power minus 3, as you can see now I've introduced brackets. These brackets mean that the power affects everything inside the brackets. So both 2 and y are affected by the power minus 3. So that means that I'll invert both and then I'll raise both to the power 3. So both 2 to the power 3 is 2 times 2 times 2, give you an 8, and then y to the power 3 is y to the power 3. So in this case, you can understand that both numbers are inverted. So here's something you would commonly see on the topic of standard form. 2 times 10 to the power 4 times 3 times 10 to the power 5. So in this case, what you should never do is to multiply 2 and that 10 and get it 20 to the power 4, or multiply 3 and that 10 and get it 30 to the power 5. Never do that. That's very incorrect, right? You need to rearrange so that these two, 10 to the power 4 and 10 to the power 5, multiply each other. And these two, 2 and 3, multiply each other. So I rearrange, I'll get 2 times 3 times 10 to the power 4 times 10 to the power 5. So 2 times 3 gives you 6 times these two add powers, 10 to the power 4 plus 5. then I'll get 6 times 10 to the power 9. You leave it like that. Unless you first of all find 10 to the power 9, which is 9 tens multiplying each other. That's a billion. Then you multiply a billion times 6 and you get 6 billion, which is a step you can take, but in most cases, for standard form purposes, it looks good like that. If you have 5 times 10 to the power 7 divided by 2 times 10 to the power 3, again, don't multiply 5 and 10. Do not multiply 2 and 10. Instead, separate, right? 5 divides of 2, and then 10 to the power 7 divides 10 to the power 3. 5 divided by 2, that's 2,5, times these two now, subtract powers, and then you get 2,5 times 10 to the power 4. Okay, so you can try the questions from the first exercise